All right, section 6.3 deals with this concept called logarithms, and logarithms tends to be one of the more abstract concepts that we cover in Algebra 2, but once you become familiar with them, they tend to be pretty cool. So we're going to jump right ahead to example 1, and example 1 looks at solving equations, okay? So solving an equation, you look at the two examples they have here. The one on the left is just like a pre-algebra problem. Okay, so I want you to really think about what would you do to solve this problem. To solve this problem, it's all about doing the opposite, okay, doing the inverse. So instead of 2 times x, we're going to divide each side by 2. Doing the opposite and allows us to get x equals 4. From there, you could check your work by plugging 4 back in. 2 times 4 equals 8. It worked out. We're good. Okay. The second equation we have today is where logarithms come into play. And for this one, we're actually going to be able to use common sense to solve, but we're going to come into some problems today where you're not going to be able to use common sense. So with this, you have 2 to the x power equals 8. You think about what is the opposite of raising something to an x power, and we don't know that yet. But we can think about this logically and say, okay, 2 to what power is going to give me 8. Okay, so 2 times itself, how many times gives me 8? And hopefully you can see that if x is 3, okay, 2 to the third power is going to give me 8. 2 times 2 times 2 equals 8. Now, like I said, not every single problem that you run into today is going to be that simple. So we have to introduce this new concept, and it's called a logarithm. So this box right here talks about the difference between exponential form and logarithmic form. For exponential form, they're going to give you a power. Okay, and it's real important to know the parts of a power. So I'm going to actually write it off to the side a little bigger. You have a to the b equals c. Okay, so in this setup right here, a is going to be our base. Okay, you can think of it because it's down below. Okay, so a is the base because it's down below. B is obviously our exponent. And then C is the result of the problem. Okay, so it's what our power equals. Okay, so that's for exponential form, which honestly, you guys have dealt with a million times. You may not call it exponential form, but that's what it is. Okay, exponential form. The new form we're going to introduce today is called logarithmic form. And for logarithmic form, it's going to be written like this, where we have log base A of C equals B. Okay, here's the key to the problem. Here's the key to logarithmic form. A is still known as the base. Okay, so the base of your exponential form and the base of the log are going to be the same. Okay, so what's down below for the exponential, what's down below for the log is going to be the same every single time. Notice here, though, that for exponential form, we have our exponent. Our log is always going to equal the exponent. So as soon as we get into logarithmic form, exponent goes to the right-hand side. And that leaves me one spot left, okay? And that's going to be the result. So C, the result, is what we're actually taking the log of. Okay, so notice as I go from one form to the other, we're just shifting these 3 parts around. The bases are always the same for each of them. And then my exponent, when we're in logarithmic form, goes to the right-hand side. So the first thing we're going to look at today is switching from one form to another. Okay, so we're just going back and forth, back and forth. So for this one right here, they want you to write the logarithmic form of y equals a to the x. Well, like I said earlier, the key to this whole problem is figuring out what is the base. Well, here's my power over here. My base is 8. So when I write the logarithmic form, my log is going to have a base of 8. Okay, the 8 stays down below. From there, you need to remember that I said the exponent is always what the log equals. So I have log base 8 equals x. And then there's one last thing we have left over, and that's y. There's one spot for it to go. There's my logarithmic form right there. So log base 8 of y equals x. We're going to be going back and forth throughout the day today. You look at example 2. For example 2, They give us a bunch of different scenarios here. For the first one, they want to know what is the logarithmic form of that setup. So 3 to the 4 equals 81. You go the same route. You got log base 3 equals my exponent of 4, 81 left over. Done. Going the other way, they want the exponential form. So my bases are the same. So exponential, I got 10. Remember, my exponent is on the right, so I'm raising it to the 3, and it equals 1,000. This is like when I go from log to exponential, these are the ones that you absolutely have to get right because like you can check it, okay? Like 10 to the 3. What is 10 to the 3? What's 10 times 10 times 10? It's 1,000, so we know we did it right. Okay, we got 2 more. It's much of the same. You go ahead, you got base. Make that a little nicer. You got base, so log base 7 equals exponent of 3. 343 goes right there. Exponential form, you can go 4 to the 2. And then the exponent equals 16. 4 squared, 16. Boom, done. Okay, so go ahead, do the try it on your own. And then we should be good at example 2. Example 3, they want you to start working these out. So I know what's the value, like what does it equal? So you gotta use a little bit of your like brains here a little bit. Log base 5 of 125. Most people that means nothing. So what I like to do is switch to exponential form. So 5, okay, we're trying to figure out what this equals. So remember, the log equals the exponent. So I'm thinking 5 to what power gives me 125? Well, I gotta do it 3 times, so it'd be 3. Same deal on the next one. What does it equal? What's the exponent? So 1/4 to what power equals 16? Well, I know 4 squared is 16, but I'm going to have to flip the fraction, bring it up top, so it has to be a -2. This one, I got 3 to what power is going to give me 0. We realize I can't raise it to any power. Okay, like if I raise 3 to the 0 power, it's going to give me 1. If I go negatives, it gives me a fraction. If I give whole numbers, it just gets bigger. So any log of 0, we're going to say is undefined. Like it just can't be done. Okay, so we got undefined. And then the last one, D, we go 2 to what power? So this looks intimidating, but it's actually not that bad. 2 to what power equals 2 to the 8? Well, the base is already the same. They're 2 and 2. So what does my question mark have to be? Has to be 8. Okay, so that is the basics for exponential and logarithmic form.